Hello friends, myself R.D. Mahajan presenting my video on Z transform. Let us solve the problem. Find Z transform of f of n if f of n is equals to two values. First 7 raised to n for n less than 0 and second value 4 raised to n for n greater than or equals to 0. Then as value exists for both positive as well as negative, Z transform is given by Z of f of n summation from n is equals to minus infinity to plus infinity f of n into z raised to minus n, splitting it, n is equals to minus infinity to minus 1 f of n. For that range f of n is 7 raised to n z raised to minus n, and second summation from n is equals to 0 to infinity f of n is 4 raised to n into z raised to minus n, and we call this equation 1. Then we have to determine a value of first separately and value of second separately, and therefore z transform of first function f of n f1 of n as summation from n is equals to minus infinity to minus 1 7 raised to n z raised to minus n. Here we use the substitution. Put n is equals to minus r. For n is equals to minus infinity, we get minus infinity is equals to minus r, means r is equals to infinity. And for n is equals to minus 1, we get minus 1 is equals to minus r, means r is equals to 1. Substituting these new limits here in this step, we get that summation from r is equal to infinity to r is equals to 1, 7 raised to n, n is minus r, and z raised to minus n, z raised to r. Combining this two by taking r common, we get summation of 7 raised to minus 1 z and whole raised to r. R changes from, we write down the limit from lower side to upper side, or lower limit to upper limit. Lower limit is here 1, upper limit is infinity. This is summation of, transferring this 7 to denominator, we get z by 7 whole raised to r. R changes from 1 to infinity. Substituting the first value of r as 1, we get first term as z by 7, next as z by 7 whole square, next as z by 7 cube, and so on. Then taking z by 7 common from all this, we can rewrite this as z by 7 common. Remaining here is one first term, second one is z by 7, third z by 7 square, and so on. This is z by 7. Sum of this type of term is 1 upon 1 minus capital X. Here capital X is z by 7. Rewriting it by cross multiplying by 7, we get z by 7 into 7 minus z whole divided by 7. 7 goes to numerator. This 7 get cancelled. We get 7 minus z as first Z transform. and the condition is here mod of z by 7 less than 1. That is nothing but mod z less than 7. Try to determine the z transform of second function. We call this equation 2. Z transform of second function f2 of n, summation from n is equals to 0 to infinity 4 raised to n into z raised to minus n. Again combining that power n, it is summation of 4 z raised to minus 1 whole raised to n changes from 0 to infinity. Summation of transferring this to denominator, we get 4 by z, that bracket raised to n changes from 0 to infinity. Substituting the limits, n is equals to 0, we get first term as 1. For n is equals to 1, we get next as 4 by z. For n is equals to 2, we get 4 by z whole square, and so on. This sum is 1 upon 1 minus capital X. Capital X is here 4 by z. All this I have discussed in my first video. Refer that or watch that video. And the condition is mod of x 4 by z, mod of 4 by z less than 1. Cross multiplying it, we get z transform as f2 bar z, z minus 4 whole divided by z, z goes to the numerator, therefore it is z upon z minus 4, and the condition is mod z greater than 4. Equation number 3. Then combining equation 2 and equation 3 and equation 1, or using 2 and 3 in equation 1, we get z transform of f of n is f bar of z. Z of first term is z divided by 7 minus z, condition mod z less than 7, and z transform of the second term is z divided by z minus 4, condition is mod z greater than 4. Therefore, this is the required z transform. Combining these two, we get that is 4 less than mod z and less than 7. This is the region of convergence. This is nothing but a region between two circles.